why we explore Mars, the mysteries of the red planet, the history of water, the possibilities of life.
You learn something and then you design the next mission based on what you learn.
Has allowed us to literally go back in time on Mars.
The first picture will cover an area of 176 miles.
Mariner 4 began transmitting back images.
The first photograph that a human being has ever seen from the surface of another planet.
On August 20th, 1975, the first Viking spaceship was launched.
You are seeing something that no other human has ever seen before.
Former seas and mountains.
Huge canyons.
That sense of wonderment and achievement and always working towards your goal.
We can do, and we will do.
And liftoff.
Touchdown confirmed.
Mars is unavoidably special.
We've landed and we've scooped.
We've roved, we've orbited.
Together we did it, but the attitude was together we can do it.
The future is what you make out of it. You can make it real.
And here we are with Mars Perseverance, 51 years later, getting ready to do the first ever Mars return mission.
Eventually, we can bring those samples back to Earth and determine for the very first time, did life exist on Mars?
In less than an hour, NASA's 300 million mile journey from America's shore to Jezero Crater on Mars will begin with the launch of this Atlas V rocket into space. And at the top of that rocket, with a beautiful sunrise and shrouded by that protective fairing, is the Perseverance rover headed to Mars, ready to ride a column of fire and smoke on its way to the red planet. What a beautiful morning here on the Space Coast. Welcome, everyone. Behind us, the star of the show. This is a life-size mock-up of the Perseverance rover, which is just like the one we are launching to space. Hi, everyone. I'm Daryl Nail.
And I'm Mujige Cooper. In the 50 minutes leading up to launch, we will show you how this mission will reach and search for ancient microscopic life on Mars and test new technologies critical to the ultimate goal, future human missions to Mars.
That's right, and we've got the rocket on the pad and it is ready to go. A beautiful day outside. We're L-47 minutes and counting until launch, and so far the countdown to Mars is on track. We've got great weather, the rocket's looking good, and it puts us on track for a launch at 7:50 a.m. Eastern Time, the beginning of a 2-hour window.
In today's coverage, we will hear Grammy Award winner Gregory Porter. We'll talk live with Derek Muller of the YouTube channel Veritasium, along with the aerospace engineers, scientists, and a NASA astronaut.
Oh, it's going to be a great show.
Yes.
I love it. I love it. And we have teams from coast to coast, folks, helping us count down to Mars. We will go live to the Atlas Spaceflight Operations Center, just a few miles away from us.
And we'll go live to California, to the Jet Propulsion Laboratory, where the Mars 2020 mission team is standing by to communicate with Perseverance after it gets to space.
And of course, we are here to tell you what the Perseverance mission is all about. It's an exciting day for all of us here. So we want to walk you through what you will see next during the countdown and the rocket launch. So let's send it over to Joshua Santora and Mick Woltman, who are with the ULA and Launch Services program teams. Gentlemen.
Hey, good morning, Daryl. I'm Joshua Santora, and I am here at Atlas Spaceflight Operations Center, joined by Mick Woltman from NASA's Launch Services program. Mick, you excited to go to Mars?
I am excited to go to Mars this morning, Josh. This is a great day. The sunrise out there looks awesome on this rocket, and ready for a great launch today. Thanks for having me on the show.
Man, happy to have you along, providing a ton of good context as we go through. Before we dive into the story of Perseverance, we want to give you a preview of what's ahead today in the countdown. Things really got going this morning just after midnight, actually, and Atlas V is just about ready to fly. In a few more minutes, we're going to get the final check of the weather, and that weather report should be coming back really positive. It's been great all morning. We have the terminal count ahead after that. We will be proceeding through the last few minutes of the countdown, and then the drama will be at its peak at launch. When the clock strikes 0, the engines ignite, and the spacecraft and rocket take flight. After successfully passing through max Q just shy of 2 minutes into flight, The solid rocket boosters will be expended and will be jettisoned. Nearly 2 more minutes, and the payload fairing, which you might call the nose cone of the rocket, that has been protecting Perseverance, will no longer be needed. It will split in 2 halves and fall away from the accelerating vehicle. 1 minute later, the Atlas booster will have finished its task of lifting Perseverance above Earth's atmosphere and being on the way to orbit. It too will separate, exposing the Centaur RL-10 upper stage engine that will almost immediately begin its first burn that lasts approximately 7 minutes. After coasting for more than 30 minutes, the second burn, lasting around 8 minutes, will take Perseverance out of Earth orbit and into solar orbit on its way to Mars. That sets up spacecraft separation and the final milestone we're hoping to hear this morning, the acquisition of signal. And I say hoping to intentionally because it's quite possible that Perseverance will be in perfect condition, but we won't make contact during the broadcast. So lots more to come, lots ahead. But Daryl, we're going to throw it back over to you now to tell us more about this amazing mission.
All right, thank you, Joshua and Mick. We've got a lot of really smart people and talented people that we're going to be talking to today. But let's begin with a scientist who's coming up in just a bit. I want to talk a little bit about Mujega Cooper, who's here. She is a planetary protection lead for this mission. Thank you so much. You've been working on this for a while, Moo.
Yes, this has been 7 years in the making, and I'm so excited to share this moment with you and with those that are viewing today. I'm just ecstatic.
It's fantastic, and we're in a launch period. People probably want to know, why are we launching today? Why are we launching right now? We're in a period that only comes around once every 2 years.
Yeah.
Explain that.
The orbits of Earth and Mars are on the same side of the sun so that we can reach that destination with less fuel. So it's the best time. Short journey, less power.
We like that. And we're studying the climate, the geology, and searching for ancient life. But Moo, what kind of life are we talking about here?
Well, when we search, we're not going to find dinosaur fossils, right? We're likely,
no?
unfortunately, likely we're going to find it in the form of microscopic life.
We're hoping
ancient
to.
life.
We're
hoping.
Yeah, we don't know if it's there, right?
Yeah, don't know.
Okay, well, that's why we're going.
Yes.
All right, thank you very much, Moo. And back here on Earth, our friends at Twitter are celebrating Mars 2020 in a very special way we want to let you know about. Check this out. If you
Chai, let me ask about Google. If you were forced to split up your business lines, say spin off ad tech and YouTube, can you describe what happens to consumers there?
Congressman, today consumers in most of the areas we are dealing with, they see prices free or falling, and they get more choice than ever before. So I think it serves them well.
And you're right there. So, you know, I'm not going to be on this committee in the next Congress. I am going to put my feet up and become a senior, quote unquote, statesman. But
for spacecraft.
Yeah, we've covered a lot of ground on Mars since then. So let's head out to California and join JPL's Raquel Villanueva. Raquel, what can you share about our history of exploring Mars?
Well, Daryl, in the past, we explored the red planet with orbiters and landers, but it was the ability to move around Mars with rovers that truly helped unlock its secrets. Today, I'm joined by Perseverance Deputy Project Manager Jennifer Trosper. She has worked on every single Mars rover mission for the past 3 decades. Now, Jennifer, how does today's launch fit into the history of exploring Mars?
Well, we have always been interested in Mars because it's the thing that's most like Earth that we know of. And it's a little bit different today, and so understanding what happened to Mars will help us understand more about our solar system and also more about Earth. Now, as we said, Mars exploration started in 1965 with the Mariner spacecraft flying by Mars. And in 1975, we actually landed the Viking 1 lander on the surface of Mars. And then after that, we started sending orbiters with more sophisticated instruments. Those instruments would do global mapping. They'd find the minerals. They'd find the topography of Mars. They'd actually study the weather of Mars. But we found out that those orbiters needed partners. They needed partners to go down to the surface of Mars and explore like a geologist on Earth would, where he walks around and takes pictures and maybe she takes some measurements. That's what these rovers needed to do, and that's really what started the Mars rover program for us. Our very first rover we sent in 1997, it was a Sojourner rover. Sojourner weighed about 25 pounds and drove all of about 400 feet. But she really showed us what value a rover on Mars could have. And so then the Mars program started the Follow the Water theme to try to understand Mars better. And the first 2 rovers that were sent to Mars to follow the rover were Spirit and Opportunity. They landed on opposite sides of Mars in 2004, and they drove 30 miles combined. And they both found evidence that there had been water on Mars in the past. But we still weren't sure whether that water fostered an environment that was good for life. And so then we sent Curiosity in 2012. The Curiosity rover was big, it had a big robotic arm, it had a drill, it had a science lab in the front. And Curiosity was trying to understand the habitability of Mars. Could Mars have ever fostered life? Could life have ever grown on Mars? And within months of Curiosity landing on the surface, she actually found an ancient habitable environment on Mars. But we still don't know if life ever did form on Mars, and that's the goal of the Perseverance mission.
Wow. Thanks, Jennifer. And now that we understand how each rover mission helped shape the other, let's get to know Perseverance.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second 2 missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
And a great breakdown of the rover there. Welcome back to the Kennedy Space Center in Florida, where our next Mars rover will be propelled into space by an Atlas V rocket. And the man who leads the company tasked with safely getting Perseverance off this planet is Tory Bruno. He is the CEO and president of United Launch Alliance. We appreciate you being here, Tory, this morning.
Oh, happy to be here.
How is the launch team doing? How are you doing?
Well, the launch team is doing great. They've been on station for hours. They're calm, they're confident, they're going through the script. I'm a little nervous, but I always get nervous before all of my 400 launches so far.
Wow. You get a little nervous. Why do you get nervous?
Well, you know, a rocket is such an incredibly powerful and complex machine. Everything has to go right. Nothing can go wrong. And it's just, it never gets old. It's always the same.
It's always exciting.
Yes.
And this is a particularly exciting mission. Talk a little bit about that. This is the largest and heaviest rover that we've ever sent to the Red Planet. So how did you configure your rocket to do this launch effectively?
Yeah, this is our second most powerful Atlas, the 541. We call it the Dominator. It's got 4 giant SRBs, each putting out 350,000 pounds of thrust to augment the center core. And so it has got the power to get out there to Mars, as well as the precision. It's the most accurate rocket in the world, because when we let it go, it's got about 200 million miles to travel on that transfer orbit.
And precision is key.
That is right, yes. So the power source for the Mars rover is a contained radioactive battery. I've seen it up close, and we had to alter the way we behaved around that.
Yes.
How has that changed your team's efforts?
Oh yes, the operations around that are completely different. Now, we have a lot of experience with these. We've flown all of America's RTGs, and we're the only provider that is certified to handle them. But, you know, it is still 11 pounds of plutonium, as you saw. And in this particular case, the one very special thing was to install it in the VIF, where we would normally never breach the containment around the spacecraft, because it has to be clean and biological free. But we created a portable clean room and brought this nuclear battery out and installed it in the machine while keeping everything perfect.
Awesome. Can you explain what the VIF is, actually, before I let that go?
Yeah, the VIF is the Vertical Integration Facility. So these rockets are so gigantic, we build them in a factory, but we can't assemble them there. Atlas and Perseverance are standing 20 stories proud right now on the pad. So they come to Canaveral in pieces on our rocket ship, and then we assemble them in the Vertical Integration Facility. And normally the last thing would be to bring an encapsulated, under the fairing, perfectly clean and prepared spacecraft and put it on top, which we did, but then we opened it to install the MMRTG battery.
Yes.
And that came later in the process, and that was intentional.
Yes.
You mentioned there's a certification for who certifies the rocket?
So NASA certifies the rocket, and then NASA and the Department of Energy certify a provider like us to handle a nuclear payload because of all these special requirements.
Very good. You know, when you were preparing for this mission, you couldn't have imagined, a year ago that you would have a coronavirus pandemic wreaking havoc on this state. How did you handle that, and how did you overcome it?
Yes, well, you know, the one big lesson learned here is you can't buy back time. So when this broke out, our response was early, it was aggressive, and fortunately it was effective. So we did all the things you might be familiar with. You know, we wipe down every surface every hour, we deep clean every evening, we are wearing PPE, we have our teams spread out, we actually change the flow of the work to keep our people safe, but to also keep these vitally important missions going. And of course, I can't say enough about our team. They're so disciplined and so courageous to persevere through all of this, and now to make our third launch under all of these mitigations. I'm just so proud of them.
Well, Tori Bruno, CEO of United Launch Alliance, we appreciate you being here, sharing your knowledge with us. Good luck with the rocket launch today, and enjoy it.
Thank you very much. Go Atlas, go Perseverance.
All right.
The countdown to Mars is well underway. Let's go to our launch commentator team for an update on the pre-launch efforts and a weather forecast. Joshua?
Hey, thanks, Moo. Operations this morning have been really pretty quiet. Mick, can you tell us what's transpired to get the rocket to the point that it is today, right at this moment?
Yeah, actually, Josh, it's great to have a quiet countdown this morning. That means really good things for us here in the ASOC. But the teams did come on station today about midnight. They got on station, started configuring the launch vehicle, getting it ready for fueling, as we've been listening to them fuel the first stage Atlas with LOX and the second stage Centaur upper stage with cryogenics. The team continues to do that. They've checked out the avionics, the electrical systems. They've also done a flight termination system check with the range. So all systems are looking nominal, and the team is now currently in their T-4 and holding, and just assessing the telemetry and the launch vehicle as we get ready to lift off this morning.
Yeah, and it is a programmed hold, so this is part of the plan. This is not anything going wrong. We do have a 2-hour window today, but everything is charging ahead towards that 7:50 a.m. Eastern liftoff time. We want to introduce you to a few of the teams involved this morning. We want to start with the U.S. Space Force. They're responsible for the range operations and weather activities. So, Mick, tell me about the range really fast before we get this weather briefing in just a few seconds.
Yes, the United States Space Force is responsible for public and personnel safety here at Cape Canaveral Air Force Station and Kennedy Space Center, where we're launching from. So a very important part of the mission today. They are one of 5 teams that are working with us to launch Mars Perseverance on its way this morning. And an important part of that, not only public safety, but is they also do weather for us to make sure that everything looks good. As we saw that sunrise this morning come up right behind, everything is looking good. So.
RC, LC, that one. RC, conduct weather briefing on Channel 8 weather conference. Roger.
Sorry, we thought we were going to get that for you live, and apparently the audio is on another channel. Forgive us.
You should be looking at a visible satellite image. We have now mostly clear skies, a few clouds off to the east over the water. We were monitoring one cell on the radar 10 miles to our southeast, which has dissipated, so things are looking great for launch. We are go on all LCCs and expected to remain go through the count. Our temperature is currently 80 degrees. Could climb to 82 by the end of the window. Winds are currently from 220, 8 knots sustained with peaks to 10 knots. 10% POV for the cumulus cloud roll. Proton flux is at normal background levels and expected to remain so through the count. And this concludes the weather brief unless there are any questions.
All right, so I think we're in good shape. We heard a great report there. Again, hearing the go on all LCCs, the launch.
Absolutely.
LCC.
Launch commit criteria.
I can never remember the second C. Appreciate that. So tell us about the T clock, because obviously we mentioned we're at T minus 4 minutes and holding, so we have a difference here in these 2 clocks today.
Yeah, so the teams actually are working to 2 different clocks. The L clock, or what we call the launch time, or L minus time, is the real-time clock, which continues to count down towards liftoff. T time, that's the clock that the team uses for operational sequences of events in the procedure. This time has built-in holds in it, one of which we're in right now, 30-minute hold, which allows the team to adjust things that they need to do throughout the countdown tonight. So the L clock will continue counting down, and what's unique about this is at L minus 4 or T minus 4 as we pick up the count, these 2 clocks will sync up and we will count down to liftoff this morning.
One of the things we want to kind of piggyback off of the weather briefing for is to talk about the power source for Perseverance. Perseverance actually has a nuclear battery, which that might be a little bit alarming for people to hear that. It's not a nuclear reactor, it's a nuclear battery, and it's actually something that has been developed by the Department of Energy for this kind of a purpose. It's a multi-mission radioisotope thermoelectric generator, which is a mouthful, but it's an MMRTG. It's roughly the size of a 5-gallon bucket, and it is designed to actually make, how does this actually produce power for the robot?
So it's using nuclear material inside, right, to generate the electricity that's there. Starting off the mission today, it'll be about 110 watts of power that provides the spacecraft as we lift off. And it'll provide power for Mars Perseverance throughout its whole mission life. So that's the unique thing about this battery source that's pretty neat, is that it will continue for the whole time.
Yeah. The Atlas V has a perfect launch record, so it's in good shape. So we're not expecting any problems, but if there were a contingency today, we'd want you to stay with us to talk through some of the details, and we'd be providing advisories. We have teams that have been focused on this specifically, and they're working towards making sure that everybody is safe, and our robotic explorers are safe as well. So that's going to do it for now. A great weather briefing. We'll send it back over to you, to Daryl and Moo.
Thanks, Joshua. With the countdown to Mars well underway, we want to take a moment to honor our country with the singing of America the Beautiful.
We are proud to present to you now 2-time Grammy Award-winning singer Gregory Porter. Glory Glaze, come on down.
Good morning.
For spacious skies, for amber waves of grain, for purple mountain majesty above the fruited plain. God shed his grace on thee and crowned thy good and brotherhood from sea to shining sea. America, God shed his grace on thee and crowned thy good with brotherhood from sea to shining sea.
The beautiful baritone voice of Grammy Award-winning singer Gregory Porter. That was outstanding.
It was so emotional.
If
really
I
great.
could launch the rocket right now after that, see some rockets, red glare, I say it's perfect. Thank you very much, Mr. Porter. We appreciate that. So, Perseverance will seek to unlock many mysteries about Mars, but remote scientific instruments can only go so far.
Joining us now to talk about returning Mars samples back to Earth is Dr. Lori Glaze, Director of NASA's Planetary Science Division. Thank you so much for joining us today.
It's my pleasure. Happy to be here.
Yeah. First, can you talk to us about the value of studying Mars samples here on Earth?
You bet. So one of the most exciting parts of this mission, of course, is that we're going to drill samples that we're going to go back to Mars and pick up and bring back to Earth. And part of the reason for that is, or the main reason is, that we can only go so far with the instruments that we have on the rover. They're wonderful, it's a great suite, but nothing compared to the state-of-the-art instruments in the laboratories around the world. So we really want to get those precious samples back here so that we can do that really in-depth analysis of the samples here. In addition to that, not only do we want to study them now, today, with those state-of-the-art instruments and facilities, we can preserve actually most of the sample for decades, and that will allow us to use future instruments that haven't even been invented yet, or answer questions we haven't even thought of yet. So it's really important to get those samples back here.
And could we confirm life if it is there with the instruments we have on the rover, or would that actually happen back on Earth?
I fully expect we won't be able to make that real determination until they're back here on Earth. We expect with the instruments we have on board to be able to detect biosignatures and the types of things that say, yes, this is a sample that may contain evidence of past life in the sample, but I think it'll be very difficult to confirm that until we actually get the samples back here on Earth.
Speaking of getting them back here to Earth, the key part of this, how will you do that?
That's a great question. We're already starting work on that next mission called Mars Sample Return. We think it's going to launch. We're planning for a launch in 2026. This is a really complex mission. It's going to require 2 launches from Earth and 1 launch from Mars in order to get those samples back here.
Wow.
We're working really closely with the European Space Agency, our core partners on this mission. So we'll have a launch from the U.S., which will launch a sample return lander that will land on the surface carrying a fetch rover that will go out and pick up the samples, bring them back, load them into a rocket, the Mars Ascent Vehicle, and launch them into orbit around Mars. At the same time, when we launched from Earth, the Europeans are also launching an orbiter from Earth that will be in orbit around Mars, and it will capture those samples with that orbiter. We're going to capture them, and then it will make its return trip back to Earth, release them, and they'll come down and land in the Utah desert, where we will then safely carry them and put them in the curation facility.
Wow, what a process.
Awesome.
Yeah.
That is so amazing. Thank you so much, Lori, for joining us today. We appreciate your time.
pleasure.
Enjoy the launch. Get a view.
Go Perseverance, go Ingenuity.
Awesome.
Thank you, Lori. Well, in the early 1900s, the Wright brothers proved powered flight was possible on Earth. Now, NASA plans to test a powered flight on Mars with an ingenious helicopter. So, let's get back out to California now, and Raquel, the Martian atmosphere is 99% less dense than here on Earth, so this is no easy task to fly on Mars.
It is, Daryl. Now, hitching a ride on the Perseverance rover is an exciting technology demonstration. The Mars Ingenuity helicopter. Now, if successful, it would mark the first time humans have taken powered flight on another planet. Ingenuity's project manager, Mimi Ung, joins us now to talk about the set of milestones Ingenuity needs to hit in order to take flight on Mars.
Hi, by the way, we just had an earthquake in this room. But anyway, with that, Mars helicopter tech demo is motivated by the potential of adding the aerial dimension to space exploration. In the future, a helicopter can serve as a scout for rovers and astronauts. A helicopter can get us to places of high scientific interest that cannot be reached today. It's not easy to build a rotorcraft for flight at Mars. The atmosphere there is very thin, about 1% compared to that at Earth. So a helicopter for Mars has to be very light and have a rotor system that can spin very fast. Behind me is a full-scale model of Mars helicopter Ingenuity. It's very light, 1.8 kilograms, about 4 pounds. It's capable of flying through the thin atmosphere of Mars and is capable of surviving and operating autonomously. There is a set of milestones between now and Ingenuity's first flight. The very first one is when we turn on the helicopter and the base station to check their health. First time operating in true space environment. The next major milestone will be when Perseverance rover deploys Ingenuity helicopter to the surface. The deployment will also mark the first moment the helicopter starts to work on its own in a standalone manner. It will never return to the rover. And the first major milestone then will be the helicopter surviving the first cold Martian night, about minus 90 degrees Celsius. And we've designed the helicopter to keep itself warm. So we've planned for up to 5 flights in the 30 Martian days that have been set aside for our flight experiments. The flight data we get from the helicopter will inform our team the health of the helicopter and performance of each flight. The data could also include a few color photos. First ever photos of Martian terrain taken from aerial vantage. That would be true icing on our cake.
Cake, Mimi, thank you. And you're right, we did have a little bit of a shakeup, but everything seems to be okay right here so far. And we look forward to Ingenuity's first flight. And with that, let's head back to KSC as we continue the countdown to Mars.
All right, thank you, Raquel. When the name Perseverance was chosen for the rover, our country was in the early stages of the COVID-19 pandemic. Now, the name is also a fitting description of what NASA teams needed to get this rover to the pad on time. Joining us now is NASA Administrator Jim Bridenstine. Thank you very much for being here, Jim. Perseverance is meaning a lot, and that includes recently a 3.9 earthquake that we have reports of in California. Yeah. We just saw our own Mimi Ung. She said things were
L minus 12 minutes.
NSC, LC, Net 1.
Go ahead.
NSC, yeah. Transfer spacecraft to internal power.
Didn't work.
L minus 10 minutes.
Terminal count briefing. If a condition exceeds a launch constraint any time after the terminal count status check, the observer shall announce hold on channel 1, identify their station, and briefly state the reason for the hold. Flight control, perform launch on time verification.
Roger.
OSM, place SRB ignition SNA switch in the enable position.
SRB ignition enabled.
Box 2, verify CISA purge flowing GN2 to the CISA.
Verified.
OSM, verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Denver winds, this
RLM,
is Cape winds on the MetNet.
Monitor and event table in the correct configuration.
This is Denver winds, go ahead.
Verify
We've had termination of LR5 at 60K feet with
RC,
one edit.
verify solar radiation acceptable
Denver winds,
for launch.
copies.
Verified.
Launch on time verified.
Roger. LC switch to the ready position. All steps are complete prior to the status check.
L minus 8 minutes. L minus 7 minutes.
Status check to proceed with terminal count. Atlas systems, propulsion. Go. Hydraulics. Go. Pneumatics.
Go.
LO2. Go. Water. Go. Setar systems, propulsion. Go. Pneumatics. Go. LO2.
Go.
LH2. Go. Asgas.
Go.
Electrical systems, airborne. Go. Ground. Go. Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operations support.
Go.
Com.
Go.
Umbilicals.
Go.
ECS.
Go.
Red line monitor. Go. Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer. Go. Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
LD is go, and you have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 1150 Zulu.
Verified.
L minus 5 minutes, 30 seconds.
OS
LC,
start.
NSC.
Go NSC.
Spacecraft on internal power and timer set for T0 of 1150 Zulu.
Roger. OS start list data capture.
Roger.
All steps are complete prior to terminal count. LC switch is ready.
Denver winds, this is Cape winds on the MetNet.
This is Denver winds, go ahead.
We've had on-time release of LR8.
Denver winds copies.
On my mark, the time will be T minus 4 minutes and counting. 3, 2, 1, mark. 3 minutes 55.
Ground pyros enabled.
Three minutes.
Securing LO2 topping.
Atlas tanks flight pressure.
2 minutes 50.
FTS internal.
1 minute 59.
Vehicle internal.
1 minute 55.
Launch sequencer start.
1 minute 50.
Securing Centaur LH2.
Securing Centaur LO2.
1 minute 40.
Launch enabled.
1:37.
FTS armed.
One minute 20.
OCU armed.
SCS count started.
1 minute 15.
Produce ECS for launch. Roger.
1 minute 10.
Vent valves locked.
1 minute.
Rock, report range status.
Range green.
Forty seconds.
Stable at step 3.
Twenty-eight seconds.
ECS reduced for launch. Roger.
25 seconds.
Status check.
Go Atlas.
Go Centaur. Go Mars 2020.
Eight, 7, 5, 0.
Release.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1, Atlas V is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly. And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels.
Cape winds, Denver winds, MetNet.
And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good.
Denver winds, this is
We have
Cape
good
winds on the
indication of
MetNet.
payload fairing jettison and
Yeah,
Centaur
Cape winds, we'd like to
forward load
request
reactor deck
you
jettison.
take and processed LR6 and LR7 to max altitude, and you may.
And the
drop
RD-180
track
is
on
throttled
LR8
back,
at your
is
discretion.
throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation.
Copy that.
Standing by for BECO shortly. And we have BECO, booster engine cutoff, standing by for stage separation. And we have good indication of Atlas Centaur separation. And we have MES-1. RL-10 operating parameters look good. Chamber pressures are stable. This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length. And we have seen the Centaur PU system go to closed loop control. Engine response remains nominal, still seeing stable and nominal chamber pressures. And we are beginning to see the RCS system begin periodic thermal firings to maintain conditions in the loop. And the loop and bottle temperatures are beginning to converge on nominal temperatures. And initial data review of boost flight indicates slightly above nominal performance of the Atlas V booster. At this time, the vehicle is 140 miles in altitude, 900 miles downrange, traveling at 14,500 miles per hour. And we did see a minor interruption to telemetry there as we switched to a TDRS-compatible data format. Overall telemetry quality is very good. coming up on 8 minutes into flight, beginning to see the Centaur PU system balance out mass errors, seeing very stable body rates in the Centaur. And coming up on 10 minutes into flight, we have seen the PU actuator come off of the LOX-rich stop as expected, and still seeing stable and nominal operating parameters on the RL-10. There is approximately 1 minute remaining in the first Centaur burn. And we've had IIP vanish, so Centaur is now orbital. And we've had MECO 1. Engine cutoff pressure signatures look good. Centaur will coast for approximately 30 minutes prior to the next burn. RCS is now commanding 100% settling to settle propellants in the tanks. And Centaur is now adjusting its attitude for PTC roll. Body rates and RCS performance look good at this time. At this time, Centaur is 2,400 miles downrange, traveling at 17,300 miles per hour. And as we pass 13 minutes into flight, the RCS system temperatures have converged to nominal values. The Centaur tank pressures remain at stable and expected values, and still seeing good overall performance from the RCS system. Passing 16 and a half minutes into flight, an initial review of the MECO 1 orbital parameters indicate that the vehicle trajectory is very close to pre-flight predictions. and passing 18 minutes into flight, the RCS system is now commanding 25% settling. Still seeing nominal operating parameters and temperatures on that system. Also seeing nominal and stable battery voltages and temperatures as well. and passing 25 minutes into flight, seeing another minor interruption to telemetry as we change over TDRS satellites. All data at this time is indicating nominal performance. The RCS system continues to settle propellants in the tank. Still seeing stable Centaur tank pressures as well. coming up on 35 minutes into flight, approximately 10 minutes remaining in this coast period of flight. Continuing to see good performance from the RCS system, good response in Centaur body rates as we reverse that passive thermal control roll direction. Also seeing stable Centaur tank pressures and overall excellent performance from the telemetry systems. And passing 39 minutes into flight, still seeing very good performance from the Centaur main vehicle batteries, stable voltage and temperatures. Also starting to see a little bit of a response in Centaur body rates as we start to turn towards the MES-2 attitude. RCS performance and Centaur body rates appear nominal at this time. And seeing a good response in Centaur body rates as we spin down from the passive thermal control roll. In approximately 3 minutes, the Centaur engine will ignite to begin the second burn of today's mission. 33 seconds prior to ignition, the RL-10 will begin the fuel and oxidizer pre-start sequence, and this burn will last approximately 8 minutes. And RCS is now commanding 100% settling in preparation for the second burn. Still seeing nominal temperatures and loop pressures in that system. And we have fuel pre-start on the RL-10. And we have main engine start 2. The RL-10 pressures look stable and nominal at the beginning of the second burn. And the PU system is in closed loop control as well. It's controlling mass errors to near zero and seeing good response from the PU actuator. And Centaur body rates and thrust vector controller performance both look very stable at the beginning of the burn. A little under 5 minutes remaining in the burn. The Centaur body rates continue to look stable. Still seeing good performance from the RL-10 as the operating parameters remain stable and nominal, and still seeing the PU system balance those mass errors to near zero. and approximately 3 minutes remain in this second burn of today's mission. Still seeing nominal operating parameters across the board, including stable battery temperatures and voltages and stable Centaur tank pressures. About 1 minute remaining in the burn. Still seeing nominal RL10 operating parameters and nominal data across the board. And we have MECO 2, main engine cutoff. The RL10 shutdown parameters look good. And we're seeing turn to the separation attitude. RCS system performance looks good as we do that, and so do Centaur body rates. A little under 4 minutes remaining until Mars 2020 separation. Continuing to see good performance from the telemetry system, getting all around good data. Also seeing nominal battery voltages and temperatures. Approximately 2 minutes remaining until spacecraft separation. Still seeing very nominal performance of the RCS system. It's controlling Centaur body rates very well. And seeing an increase in Centaur roll rates as Centaur spins up in preparation for spacecraft sep. A little less than 1 minute remaining until spacecraft separation. And about 30 seconds until spacecraft separation, still seeing stable Centaur tank pressures, very good performance from the RCS system, and stable indications from the avionics systems as well. And we have successful separation of Mars 2020 with the Perseverance rover. And with the successful separation of Mars 2020 with the Perseverance rover, the Centaur will now perform its standard propellant blowdown sequence to inert the vehicle and complete today's flight after completing its CCAM avoidance maneuver. This will conclude today's commentary of the Mars 2020 mission. This is Atlas Flight Commentary signing off.
I'm concentrating.
Denver winds, this is Cape winds on the MetNet.